Hi, welcome to today's lesson on current and resistance. This is one of two lessons. Okay, so we'll be going to go through the basics of it today, and we'll be discussing it and developing and exploring a lot more about current and resistance next lesson. So just to get started, let's see if you can remember some circuit symbols. Pick any four, have a little draw of them, and don't forget to label them. Pause the video here and have a go. Okay, and a little bit of retrieval practice now. So again, pause the video. If you're following along on the worksheet attached, there should be 6 little boxes, similar colours. Answer the questions in those boxes. So pause the video, have a go. I know you're not keen on retrieval practice because you have to really engage that brain, but see if you can. It's one of the most important things you can do to really make sure you're bringing that information back to the forefront of your brain. So pause the video, have a go at these 6 questions now. Okay, so you should have had a little go. If you haven't, make sure you do. Pause it again. Okay, so these are the answers to those 6 questions. So today, what we're looking at today is understanding what current is and its relationship with resistance, and what does resistance mean. So what is current? Current is the flow of electrons, the flow of electrical charge through a circuit. Okay, now what affects that flow of charge, that flow of electrons? Okay, resistance does. Resistance affects it. Every component in a circuit has a resistance. So here we've got a model. We've got the little blue electrons flowing around our circuit, a bit like circuit training, flowing around our circuit. There's components within the circuit where the resistance is low because the current can easily pass through. So if you can see something in the picture where you can see the current easily passing through, that's right, the slide, they easily pass through the electrons, so it's got a low resistance. Can you see something in the circuit that's got a high resistance, where the current will find it difficult to get through, where the electrons are going to be much lower amount of electrons, the current will be lower because it's harder for those electrons to get through. The treacle pit, brilliant. The treacle pit is going to be much harder for those electrons for the current to flow through the circuit. Okay, so what affects the size of the current? Current can be changed by increasing and decreasing the voltage, and we'll explain and we'll discuss that next time in the second of this video. The components in a circuit may reduce the size of the current, and that's resistance, like we were just talking about it. All components and wires have resistance, and it is how hard or difficult it is or easy it is for that current, for those electrons to flow through the circuit. So resistance is a measurement, okay, of how easy it is for those electrons to flow through the circuit. Now, when those electrons flow through the circuit or through a wire, what they'll do is they'll collide with the atoms in the wire, the metal atoms, and when they collide, those metal atoms in a solid will vibrate, which means that the wire will actually start to heat up. So something with a high resistance will get hot because those electrons will be vibrating at a greater speed. They'll have more thermal energy. Okay, so which one has a high resistance? Again, if you're following along on the worksheet, this is on the worksheet. Which one has a higher resistance? If you were having to walk through this crowd or on this path, which one would have a higher resistance? Okay, so I want you to think about what we've talked about and see if you can work out which one would have a higher resistance and why they would have a high resistance. So again, if you're on the worksheet, explain why. Now, I said you walk through that crowd or on that path. What are you representing in this model? Okay, if we're talking about electricity, what do you represent as you go through the crowd or down the path? What do you represent in this model? So resistance of the component, the greater the resistance, of the smaller the current for a given potential difference. So as long as we keep the potential difference the same, okay, if you have higher resistance, you'll have a lower current. Okay, if you have a lower resistance, you'll have a higher current. Okay, so progress check, pause the video, have a go answering these questions. And here's the answers to those questions. So I'm not going to read them, I'm just going to put them up so you can pause as you go through each one. So this is the last little bit. So how do you calculate resistance? We're going to use an equation called brr. So potential difference equals current times resistance. So V is the symbol for potential difference, I is the symbol for current, and R is a symbol for resistance. Okay, now potential difference is measured in volts, current is measured in amps, and resistance is measured in ohms. Okay, and it's got this funny little symbol here, and that's because it's named after a scientist called George Ohm, and he created this Ohm's law, which is this equation. Resistance is equal to potential difference divided by current, and it's a very important discovery, and this is Ohm's law. Okay, so we'll talk a little bit more as well about what Ohm's law means. Okay, so Ohm's law is usually written this way round, okay, but it can also be written in any of these formats, okay, because you can rearrange the equation. Okay, so what does Ohm's law show? So Ohm's law shows that if the voltage increases, the current increases. If the voltage increases, the current increases. They are proportional to each other. Okay, but here's a question for you to do. So calculate the resistance of a bulb. Filament bulb has a current of 0.2 amps running through it with a potential difference of 5 volts across it. What is the resistance? So the first step we need to do is work out what we are being asked to work out. We've been asked to work out the resistance in this case, okay? So we're being asked to work out the resistance. So we need to get our equation and we need to rearrange it to work out resistance, okay? Now, what else do we know in the equation? In the question, we know that the current is 0.2 amps and we know the potential difference is 5 volts. So we've rearranged our equation. So resistance equals potential difference divided by current. We know the potential difference is 5 volts and the current is 0.2 amps. So we do 5 divided by 0.2, work it out on our calculators, will give us 25 ohms, and that's our funny little symbol for resistance. Okay, so we're going to have a go at some more resistance calculations now. So here's some examples of some calculations involving resistance, potential difference and current. So I'm just going to show you some examples and work through how to calculate the answer. So the first question here we've got is calculate the resistance of an appliance with a potential difference of 9 volts when the current is running through it is 1.5 amps. So the first thing I do is make sure I highlight the numbers in the question. Then I work out what the question is asking of me to do. So it says to calculate the resistance. So I know that I need to work out the resistance. That is what I need to work out. So the resistance is what I need to work out. I have been given the information about the potential difference. So I know that the potential difference, which has a symbol of V, is 9 volts. And it tells me that the current is 1.5 amps. So the current, which has a symbol of an I, is 1.5 amps. Okay, so we know the 3 values in our question. So what we need to do is put them into the equation and work out the answer. So what equation links resistance, potential difference and current? It's the one that we've been looking at, which is potential difference equals current times resistance. So I'm going to start with it in that version, and we're going to use our fat nans are useless system to make sure that we get the full marks. So the F stands for the formula. So we know that V equals I times R, or potential difference equals current times resistance. Okay, so what I'm going to do next is I'm going to put in my numbers. So the potential difference V is 9 volts. So 9 equals current, which is 1.5 times resistance that we haven't worked out. I'm then going to rearrange my equation to give me the resistance. So resistance equals 9 divided by 1.5. Okay, potential difference divided by current. Okay, so I'm going to put that into my calculator. 9 divided by 1.5. Remember, you are allowed a calculator in the exam. So the resistance is equal to 6. And then our last bit, U, stands for the units. Okay, so what we've got is resistance equals 6 ohms. Remember, resistance we calculate in ohms. So this is the first of a set of questions on the worksheet. You can use this to help you answer questions part B, C, D, and so on. Question 2 on the worksheet, I'm going to go through the first one with you again and show you how to work it out. So calculate the current passing through a 12 ohm resistor when it has a following potential difference of 1 volt. The first thing I'm going to do again is just highlight my numbers. Second thing, I'm going to work out what the question is asking me to do. It's asking me to calculate the current. So the current, I don't know. Okay, it tells me some information. So 12 ohm resistor means that the resistance is 12 ohms. And it tells me that the potential difference is 1 volt. So again, we've got our same equation, V equals I times R. We're using our fatnans are useless, formula, number, answer, unit. So our formula is potential difference equals current times resistance. We're going to put our numbers in. So potential difference we know is 1 equals current we don't know. I'm just going to make that a capital I so we can clearly see it. Times resistance, which is 12. Now I'm going to rearrange that to give me the current is the thing that we're trying to work out. So current is going to be equal to the potential difference divided by the resistance. So where's my potential difference? Is 1 divided by resistance is 12. Okay, so 1 divided by 12. So I put that into my calculator. Gives me an answer. So A for answer is current equals 0.08, and then my units 0.08 amps, and there's my answer. Again, this is the first question on the worksheet for question 2. You can work through B, C, D using a similar system. And finally, on the worksheet, the third question is this one. So here's a worked example for this one. Okay, so calculate the potential difference in the following scenarios. So here's my numbers. So highlight my numbers, work out what I'm being asked to do, calculate the potential difference. So V, I don't know. 12 ohms, that's my resistance. So 12 ohms is my resistance. Current is 5 amps. So again, I'm going to put this into my equation. So fatnans are useless. So formula equals V equals I times R. So put my numbers in, N for numbers. V we don't know. I is 5 times resistance, which is 12. 5 times 12, work it out. Gives me an answer of 60, A for answer. And my potential difference is 60 volts, U for unit. So that is the third question. Worked examples, you can now continue with the rest of them on the worksheet. And finally, for this lesson, can you complete the exit task attached to the lesson? Okay, well done. Thank you for showing up. Great work today. Don't forget that this is 1 in 2 lessons all about resistance. So next lesson, I will be sharing with you some more content about how resistance works, and we'll look a bit more about Ohm's law. Thank you.